When learning long division, I found that I wasn't consistent with it and I wasn't able to understand the fundamentals of why it worked, which led to poor results on tests and a poorer understanding of the essential algebra to do calculus. So I wanted to give this explanation of underneath the hood, how synthetic division works. This is a very high level, so let's turn it into something that we understand better like FOILs and work our way up into why this technique works in the first place. All right, so let's begin with what this actually means. So this means that we have x plus 1 as a divider. We're trying to find the quotient and the remainder. And we know the dividend, which is 2x2 plus 6x plus 6. Synthetic division is simply trying to find these two parts. Now, how do we find these two parts? I'm going to begin by actually giving the answer to this specific question so that we can see how it's composed and how synthetic division helps in that composition. Now, looking at the answer, this is the divider. The quotient is 2x plus 4, and the remainder is 2. And how do we come up with the dividend? Anyone who is familiar with the FOIL technique will know this, but I wanted to color code it to make it very clear how it's composed so that later we can decompose based off of those two. Of course, we have the leading variables multiplying, the two variables multiplying by each other to get the first term. The second term is the variable multiplied by the constant in the other terms, right? So they kind of switch places in that place. And the third term is simply the two constants times each other plus any kind of remainder that remains. So we know that in case 6, 6x, and 2x squared. Now, this is the actual answer, but when you're doing synthetic division, what you're really doing is you're beginning with this. You know the quotient, the the dividends, the divider, sorry. You don't know the quotient, and you don't know the remainder. Fundamentally, the math is the same, it's just with more variables. So what synthetic division does is allow us to solve for each of these pieces one at a time, so that we have the variables that we need to get to the other part. For example, if we figure out what a of x is, we can then figure out what c is, which will lead us to the second term. From that, we can figure out what r is because we have c. So it goes step by step. Of course, c being the constant of the second term, a being the coefficient, and r being the remainder. Okay, so we'll turn this into the format of a synthetic division, which is the x plus 1 brought down. Now, typically, you're going to be taught to reverse a symbol, so make this a -1. It is useful, and I will explain why it's useful, but it's not required. Then we have 2, 6, 6, which are just the coefficients, and in this case, the constant of, I guess you can call it coefficient of x0. So we have all those. Now, how does this actually work? Like, what sections are inside of synthetic division? We have a section of work, so where you jot down notes to get to the final solution. Of course, the solution being the quotient plus the remainder. Uh, what that looks like for a good comparison is with long division, you might have the divider here, solutions on top, you have the dividend here, and then the work is below. So it's just a bit of a different format. The only reason they reverse it is to clearly separate it from long division so that the people don't get confused. All right, so now let's begin with doing this step by step, finding each of the variables. So we know the first thing we need to find to get the first term is ax2. The great thing about synthetic division is that the only reason that it works is because the coefficient of the term that we know is 1, the degree is 1. So because of that, we know that if this number is not 1, that number must be the coefficient of x in the second term. So in this case, it's very simple. We write x. We write x, 2, which what that means, if you look at it from the solution point, is that we know that if we have x plus 1, that 2x is the first term. And of course, it's 2x because if you do x plus 1 times x would lead to x2. So we know that we have to remove an x to make sure that the end result is x2 in this case. Perfect. So we have 2. we now know this. So now we know that it's x times 2x, which is equal to 2x2 right on top. Now let's try to find 6x. So we are missing one variable in this now, which is c, because we know this. So we know that it's x multiplied by c plus 2 of x is going to equal 6x. So of course, in this case, the simplest thing we can do is minus the 2x. So we go 6x minus 2x, which is equal to 4x. So now we found what the c term must be, which is 4, in order to be multiplied by x and get 6x. So that's how we found it using a more traditional technique that is closer to the actual core. But synthetic division makes this quicker by having the technique of, all right, so now we have 2 times 1, which is 2, and we can remove that from 6. So 6 minus 2 is equal to 4. And of course, this is where you can flip the symbol here. So let's say that you were to do -1. So, because x plus 1, you decide to flip the symbol as you're taught in class. Then all that happens is that you're adding in this case, but you're adding -2. So the answer is the same. It's just a bit of a shortcut. Doesn't it's convenient, so it's worth to do. It's worth doing it, I guess. Yeah. So now we have 4. So we know it's 2x plus 4. Now we need to check if there's a remainder. There are really two ways to check, but it's better to do it with synthetic division. The traditional ways, of course, just FOIL all of these out and see the difference. Because if you FOIL all these out, then if it's not 6, whatever the difference is to make it 6 is what you add as a remainder. But looking at it from this way first, we know c is 4. So now we have 1 times 4. 1, of course, just being x plus 1 times c, which now we know is 4, plus the remainder would equal 6. So we know that it's just, if you just do a little bit of 6 minus 4 equals 2. But if we were to do it in long division, I mean, in synthetic division, the way you do it is you grab the 4, multiply it by -1, then let's say plus -4, which is equal to 2. So now we know that the remainder is 2. All right, so that is how we found this out in terms of long division, I mean, in terms of synthetic division from behind the hood. This is the underlying way and reason that it works, this format here. Synthetic division just aims to speed that process up. And I hope that really kind of helps you understand it from a higher level perspective, because with that understanding, it's much easier to understand other concepts that are essential to doing well, such as a factor theorem. And yeah, so if you have any kind of questions about it, leave any comments below. I'm also a fellow student of mathematics, so I would love to learn any kind of new points from you guys. And thank you very much. I hope this was helpful to you.